The objective of the project was to build a low-resource ventilator that can do constant mandatory ventilation using pressure and time controls, using only parts sourced from a hardware or an auto parts store, with the additional capability to do a synchronous mode if you're able to source a microprocessor to control the timing. All right, the first component in the ventilator is a pressure regulator. So we set the pressure regulator to 15 psi. Then we also have an input for compressed oxygen if that's necessary. So the two gases are combined and go to the inspiration valve. In this case, the inspiration valve is an off-the-shelf irrigation valve from Home Depot. The second component, or the next component in the system, is a manual gate valve, and we use that to drop the pressure a little bit further. And then we have a third valve, second manual valve, third valve in the system. And we use that so that we can we set it so that we maintain a higher pressure in this part of the system than we have in this part of the system. And the reason we do that is we need high pressure in this area to close the pinch valve, and I'll explain that in a minute. This is the PIP valve, so air path, this tube goes down into a column of water, and you set the PIP pressure by adjusting the water height. This also is a safety valve, so if you ever had a severe overpressure in the system, it can't exceed whatever you have this set to, because the air will just blow off through this valve. This is the anti-asphyxiation valve, which is essentially a check valve. This is the inhale detect switch. It's effectively a brass fitting with a penny, and whenever the patient inhales, the two make contact, and then that tells the controller that an inhale has happened. And then we have the manometer. So the manometer is how we set pressure, measure pressure. So you look at the graduations on the side here, we go from 0 up to 80. So then this is the inhale side, this is the exhale side. The two are tied together with a T, and so this section of the T would then go to the patient. So after inhale, we have the exhale path, comes this way and then goes through the pinch valve. Now, what is a pinch valve? So there is a rubber bladder inside of here that when this pressurizes this PVC and closes that rubber pinch valve. And that closes the exhaust path or the exhale path so that the pressure is sent to the patient, so that the inspiration pressure is sent to the patient. When this valve closes and the inspiration is over, this valve opens and allows the patient to exhale. The final stage in the exhale path is a PEEP valve. And what this does is maintains a certain amount of pressure in the lungs. It doesn't allow the pressure in the lungs to go down to 0. And you set this the same way. There's a column of water here. This tube is inserted in that column of water by some amount. 10 centimeters is what we're going to show you how to do.